Welcome to Spring Lib.
In this exercise, we have a car that's parked on a steep incline that makes an angle of 37 degrees below the horizontal. And 50 meters after the point where the car is parked, there is a vertical cliff, and the cliff is 30 meters high, and below the cliff, there is the ocean water. At a certain point, the car starts accelerating downwards with an acceleration of 4 meters per second. And in question A, you have to find what is the final speed of the car when it reaches the edge of the cliff. So notice that the total distance traveled delta r is 50 meters. The acceleration, of course, is 4 meters per second squared. And the initial speed is just 0 because the car was parked. And we can use Torricelli's formula that says that Vf squared is equal to V0 squared plus 2 times the acceleration times the distance traveled. So V0 is 0, Vf is the square root of 2 times the acceleration a, which is 4 meters per second squared, times delta r, which is 50 meters. So this is the square root of 400 meters squared per second squared. So Vf is equal to 20 meters per second. This is the answer to question A. In question B, you have to calculate how much time passes between the car starting to accelerate downwards and the point where it reaches the edge of the cliff. And notice that the variation in speed of the car is just Vf, that's 20 meters per second, while the acceleration is 4 meters per second squared. So the time, we know that the time is equal to the variation in speed divided by the acceleration, and this is 20 meters per second divided by 4 meters per second squared, and this is 5 seconds. In question C, we have to find the velocity of the car when it reaches the ocean. Notice that the speed of the car when it is released from the edge of the cliff, so when it starts its projectile trajectory, is just the speed Vf, so I'm going to call it V0 prime is equal to Vf, that's the initial speed of the car along when it's freely falling. And for that reason, V0x is just Vf times the cosine of 37, because the car is released 37 degrees below the horizontal. So this is 20 times the cosine of 37, which is 0.799, and this is equal to 16 meters per second. We can also calculate the initial speed V0y, and that is V0 times the sine of 37. So it's 20 times the sine of 37, which is equal to 20 meters per second. Okay, but notice that here the speed V0y is pointing downwards. Okay, I only wrote it with a positive sign because we can consider that the y-axis is pointing downwards. It doesn't matter which choice we make for the y-axis. Notice that the horizontal velocity is constant throughout the trajectory, so it's always going to be V0x prime, while the vertical velocity changes. So we have V prime equals V0y prime plus 2gy. V0y prime equals V prime y squared equals v0y prime squared plus 2gy, that's Torricelli's formula. So what we have is that vy prime is equal to the square root of v0y prime squared plus 2gy. So this is 12 squared plus 2 times 9.8 times y. Y is the height of the cliff, and that is 30 meters. And this is equal to 27.1 meters per second. So when the car reaches the ocean, it has a speed that is equal to v prime equals v0x squared plus vy prime. We also have a prime here, squared, and this is equal to 16 squared plus 27.1 squared, and this is 31.4 meters per second, while the angle theta that it makes with the horizontal, theta is the arctangent of vy prime divided by v0x prime. So this is the arctangent of 27.1 divided by 16, and this is 59.4 degrees. In question D, we have to calculate the total time that the car is in motion. So the total time is the time it takes rolling down the steep incline, which I'm going to call T1. We have already calculated that in question B, and that is 5 seconds, plus T2, which is the time that the car spends freely falling. And we can calculate that by noticing that the final speed in the y direction, vy prime, is equal to 27.1 meters per second. The initial speed in the y direction is 12 meters per second, as we calculated in the previous question. And the acceleration is just gravity's acceleration. So for that reason, the time is the variation in the speed divided by the gravitational acceleration. So this is 27.1 minus 12 divided by 9.8. And this is equal to 1.55 seconds. So the total time, this here is to 2, the total time t is equal to t1 plus t2, and this is equal to 6.55 seconds. And finally, in question E, we have to find the position of the car relative to the base of the cliff when the car reaches the ocean. Well, that means that we have to calculate how far horizontally the car is from the cliff. And this is just the horizontal distance is v0x times the time t2 when the car was in free fall. So this is equal to 16 times 1.55 seconds, and this is equal to 24.8 meters. And this